All right. Day 13, shuttle search. Your ferry can make it safely to a nearby port, but it won't get much further. When you call to book another ship, you discover that no ships embark from that port to your vacation island. You'll need to get from the port to the nearest airport. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. At timestamp 0, every bus simultaneously departed from the seaport. After that, each bus travels to the airport, then various other locations, and finally returns to the seaport to repeat its journey forever. The time this loop takes a particular bus is also its ID number. So the bus with ID 5 departs at 0, 5, 10, 15. 11 departs at 0, 11, 22, 33, and so on. And then if you are there when the bus departs, you can ride the bus to the airport. Your notes, the puzzle input, consist of 2 lines. The first line is your estimate of the earliest timestamp you could depart on a bus. The second line lists the bus IDs that are in service according to the schedule company. Entries that show X must be out of service, so you decide to ignore them. To save time once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will be exactly 1 such bus. So if you have the following notes, the earliest timestamp you could depart is 9:39, and the bus IDs in service are 7, 13, 59, 31, and 19. Near timestamp 9:39, the bus IDs that depart at the times marked D. These bus IDs depart at the times marked D. So we have 7 at 9:31, 31 at 9:30. And so the earliest bus that you could take, it would have to be after 9:39, which is your time, and then it would be 9:44. 9:44 would be the earliest. It'd be 59, and you would wait 5 minutes before it departs. Multiplying the bus ID by the number of minutes you need to wait is 295. Okay, so that's pretty straightforward. What is the ID of the earliest bus you can take to the airport multiplied by the number of minutes you'll need to wait for that bus? And then your puzzle input is, these are when they're not in service, looks like. Oh wow, okay, so then they're giving us this really high number for when we are departing. Okay, so we do need to parse this input. X means not in service, so we can ignore it. So yeah, that's what they're showing us here on this schedule. It's a 7, 13, 59, 31, 19. So 59 is going to be, let's first parse this input here. And then we'll have a way of extrapolating that. Okay. Kind of formulating an idea of how I'm going to approach this. Make this package like I usually do. Usually just do a day 13 package. In here, oh actually this is my test. I'm just going to write a day 13 test. It's a class. And then usually what I do to start these off is just parsing the input. So we have, these are our notes. The first one is the time that we're leaving, and the second one is the time of the bus schedule, basically. So the parser is basically going to just be, we want to get a list of the lines and then break those down into, the first line is going to be time that we're leaving, the second line is going to be bus schedule, and then we can slice those up into the buses. So bus with ID 11, so on. It's going to be interesting. There's going to be a lot of possibilities given this input. So I wonder, the brute force solution would just be to multiply out, or I guess you could divide by, I wonder if there's a shortcut here where, 939, is that divisible by any one of these numbers easily? And then you still need to find the one after that, so not sure if you want to just multiply those out a certain number of times and then find the buses around there. Yeah, anyway, I'm going to parse it for now. There, I need to make a test, add test. We're going to do parse input. Test util. What are we doing here, guys? There we go. Parse input. And then we're going to pass in this class so it knows where we are. And then we want to have, we're just going to do this test input real quick here. Make a new file for this. Day13.txt. Parse input, this file name. And then day13.txt. And then our mapper. And this is the number of lines, and we don't really care about this. If I don't have, okay, I'm just going to do read lines for this. Read lines. And I think I'm going to make a separate function for parsing the input. It's going to be a private fun, parse input, and then I'll give it a file name. And then this is going to return, I think what I want is a pair. So I'm going to have a pair of an int, which is our time, and then a list of int. So we're going to read the lines here. I'm going to cut that. So read the lines, val lines equals this, and then the first item in the, oh, I think I do actually want to, let's see, I do have to convert this to an int, but I'm going to worry about that in a second. So I'm going to return a pair of lines 0. The first one is just, we're just going to go straight up to int, right? And then the other ones we need to, they're separated by commas. So lines 1 dot, we're going to map this. First we want to filter it. Filter, and then we want it not equal to x. Actually, even before that, we want to split it. Dot split. And we want to split it on comma, right? And then we want to filter. We want to filter out the x's because the x means that the bus is not in service. And then we can just do a map this to an int. There we go. I think that's our list. And so we want to, I need to import that. Okay, so parse input at this file name. We need to actually do something with that. parse input day13.txt. Input is this, and then input in, if I can type, input 0 or dot first. Equals 939 should be, I think I can actually do should be, no, should be there. 939 input dot second dot size should be, and we should just make sure that this is not giving us the buses that are out of service. So really we have 1, 2, 3, 4, 5. The size of this should be 5, and then I'm going to set a breakpoint here and just manually check that the input is what I expect it to be. Okay, 7, 13, 59, 31, 19. Yep, looks good. All right, so now we have it parsing correctly. So now let's just do a brute force solution of this. I have a feeling this might not completely work for this input because this is a huge number, and maybe there's some kind of optimization that we can make around this. I don't know yet, but let's just play with it. Test, fun, solve, example 1. Okay, so val input, we're just going to copy this. This one here, input is this. Val buses is input dot seconds. And then my time, I'm going to call it goal time, is input dot first. And we basically need to figure out what items multiply, what is the closest multiple that's greater than the goal time. So if we divide 939 by 7, we get 134. And if we take the ceiling of that, so 135 times 7, oops, I can type, 135 times 7, that's going to give us 945. So what we could do is just take this goal time, divide it by, I'm trying to think of a fast way to get a list of, we basically want to get a list of items that are, we want to get a list of these times that are just after this. And these are going to be even intervals. So I can't, it's not like I can just do 135 point something times 7. These have to be integer values. So I think I can just do 2 operations. One is take the goal time, divide it by 7, take the ceiling of that, multiply 7 by that, put it in a list, and then do that for every item in the input, or in the bus's input, and then find the minimum of that. And that's going to give me the minimum time that's after the goal time. I think that'll work. So let's do this. Buses dot map, and we want to do we do have to keep track of which bus it is. What is the ID of the earliest bus you can take multiplied? So we do have to track the ID. Okay. I think I might create a class it's a bus class that will have a method on it that can generate the time that it will run closest to that. So in my main, I'm going to create just a simple data class for buses. Day 13. Bus. This is going to be a data class, and then it's going to have a val ID, and that's going to be an int. And then I'm going to make a method called funGet closest time to, and then I'm going to have a goal time that's an int, and this is going to return an int. What I'm going to do is take this goal time divided by ID, and I'm going to take the math, I'm going to take the ceiling of this, and I'm going to multiply it by the goal time. And this needs to be a long. I think I can just convert this to double. To double. To double. Let me just have trouble with this math in Kotlin. So it requires goal time divided by this, or divided by ID. Required double. No. Ceiling of goal time divided by ID to double. Why is that not working? Can I just do 2 int? Okay. Ceiling of this, and then we want to multiply this by times ID. Okay, that's fine. So that'll give us the closest time. So that's essentially the same thing as taking 939 divided by 7, rounding it up, multiplying it by 939. And that will get us the closest time to that's an integer value. Because the ceiling rounds it up to the nearest int. Okay. I want to test this out real quick. We want to have a bus with ID 7. And then val goal time, actually bus dot get closest time to 939 should be 9:45. And it worked. Okay. So now we just want to map this into a bus. And I actually think now what I'm going to do is instead of converting this to an int, I'm going to return a bus of this. Now that I have this handy class here. So this is going to be a list of bus. Okay, so now I have the buses. I want to map this to a pair of the bus. This is, yeah. I need to keep track of Actually, I think Kotlin has a function that's minimum by, right? Min by or null. Here we go. Min by or null. So we can get the minimum by get closest time to goal time. Min.id. So we're thinking that the ID is 59. Yep. Okay, and then min.id times goal time. Oh, it's the number of minutes that we'd have to wait. So we also have to save that. Times min.id should be 295. Okay, so I think we have a brute force solution to this. There might be a better way to do it, but I'm just going to brute force solve it for now. Solve full input. So I'm going to just do solve part 1. Parse input. I'm going to make a day 13 full.txt. Here's our puzzle input here. Print that out. And we get 3,215. Does seem like a little bit of time to wait. So I do wonder about that answer, but that's the right answer. Okay. I'm going to stop this now just to break this up into part 1, part 2. That's what I've been doing lately. So I will see you in the next one.